about stacks, what they are, how we can implement them, and how exactly we can make use of them with the help of ADT, which is abstract data types, and also making a stack with the help of typedef struct. So first of all, let's deep dive into what stacks are. Stack is a data structure which consists of a set or a sequence of data arranged in the form of a open-ended stack. Well, and it follows the LIFO principle. LIFO stands for last in, first out. So what happens here is that when we put an element into a stack, we put it in an ordered form. First element, second element, third element, fourth element. They are all stacked on top of each other as the English language goes. And when the last element is put in, it is the first to come out. Like in an event of taking those elements out again, the fourth element here would be the first to come out, and the first element would be the last to come out. So it's the last in, first out principle. Stack is used in multiple real life scenarios like compiler design or undo redo in your browser functions, or a stack is also seen in a lot of real world applications like putting on bracelets or bangles, or stacking things onto each other, or the common game which goes by the name Towers of Hanoi. So basically this is how stacks function and how they are. So now let's understand how stacks are built with the help of ADT and what are the different functions you can perform onto them. So today we'll be learning about the different functions that can be performed on a stack. And here are the 5 basic ones. One is a push function, a pop function, a peek function, or sometimes it is also called a top function. And then there is an isEmpty function, which is usually a boolean, and an isFull function. Now let's go through all of these one by one. The push function, as it might sound pretty obvious, that when we push an element or we insert an element into a stack, we call it pushing an element. It is a push function. So we pushed one element into the stack. And when we take this element out, it is called as the pop function. So in the event of pushing an element, we stack them on top of each other, and in the event of popping an element from the stack, we take them out one by one, and which follows the last in, first out principle. The next function that we're going to learn about is the peek function. So in a stack, the topmost element can be accessed or can be seen by using the peek function. So as you might infer from this, that you are having a look at the function or you're peeking at the topmost element of the stack. So this is the peek function or the top function. We don't push anything, we don't pop anything in this function, we just have a look at the topmost element of the stack. IsEmpty function is used to check if the stack is empty. So if the stack is empty and it has no elements in it, the isEmpty function is going to respond well. And same goes for the isFull function. When the limit of the stack is reached after a certain point, it gives a positive response for the isFull function. So enough with the conceptual understanding of stacks. Now let's move on to the code and how we're going to design this particular data structure with the help of typedef struct and the different functions that we can perform onto it with the help of pointers, and how in general are we going to make this ADT. So first of all, we're going to explore this in the C language because it's the most primitive and the basic one. All the other languages like C++ and Python were built on top of it. So let's go on and explore this. So we're going to put in the headers right now. And I'm going to make a small little stack for you. So here we're going to define the maximum limit. I'm going to define the maximum limit of my stack, which is the point at which it is considered to be full, as 100. for my own purposes. You can define it as any where between 1 to, I don't know, infinity, but yeah, it's a general convention that we take, that when we are defining a stack, we're trying to make an ADT out of it. We usually go through this entire process of defining a max variable, which is kind of the limit for the stack. Now let's move on to the ADT type def. So as you can see here, I've made an ADT here, which is the typedef struct of a stack. I have put some lines of code together to make a stack, and the different variables inside it and the different parameters that are inside it, they kind of are the characteristics for the stack. Here I have taken an array, which is the array for holding the data of the stack, and it has the maximum capacity of max, as you can see here. And I've also taken a top function, a top variable, which can basically assess the topmost element of the stack always. So now let's make an initializing function. I'm gonna name it init, and I'm gonna take the argument as a stack. And here, let's go. Let's define this new element, this new stack that we've defined here with the help of an asterisk is a small s. So we're going to define the top as -1. This is a convention that we take. Next, we're going to define the isEmpty function, which is one of the easiest to define. So int isEmpty. So here we are going to take the stack as the argument again. And we are going to return so with the help of isEmpty function, our function is going to tell us if the top of the stack is -1, which is the basic condition for an empty stack. So what happens is, when the stack is empty, we usually call this base plate or the base of this stack to be -1. This is the convention. And if the top of the stack is this base plate, which means the stack is empty. So here we have defined this. Now the next function, which is very easy to define again, is the int isFull function. And it's going to be a stack again. Here, the condition that we're going to have is s top is equal to max -1. So here what we intend to do is that, as we know, in an array, the indexing goes something like this: 0, 1, 2, 3, 4. And when we are addressing the topmost element of the stack, we are actually referring to the last element of this array. So here we can see this array has 6 elements, but the last index is 5. So what we are essentially doing is that on the top of the stack, we are placing the maximum elements minus 1th element. So this is basically the index of this element, the topmost element. In case of a overflow condition, is max -1. So this is taken to be again a function, which is the isFull. Now we're done with the easy ones. Now let's move on to the essential ones, which are push and pop and peek. So with the help of push function, I am going to take again stack as the argument. And also I'm going to take value is the argument, which is the value that we essentially want to insert into the stack. So let's see. So if the condition what I'm trying to the logic that I'm trying to build over here is that if S has the top of max minus 1, which means if the stack is full, we want to print stack is full. And we don't want anybody to push any other element on top of it because the stack is already full and there's no space inside it to actually insert any element. And if that's not the condition, we want our data array to have this value. So we're gonna assign a new value to the topmost element of this data array, which is the highest level of this data array. So we have incremented the top of the stack by 1 and we've added a new value on top of that element. So we have pushed an element onto it and we are done. Now we're going to move on to the next function that we're going to define here, which is our pop function. And again, we're going to take the argument as stack s. No value this time because we don't want to push anything onto the array and we are not taking any other arguments as an element to insert into it. So again, we're going to make a base case here. If s top minus 1, because now here the case is kind of an inverse. So we don't want to take any element out of the stack if it's already empty, right? We don't want we don't want to take something out of a array or a stack which already has nothing in it. So here our case is that if the stack is empty, so we're gonna put printf stack underflow, or we can say the stack is empty, whatever suits you. So the else condition here is going to be printf, not printf, it's going to be the data will be removed. So first of all, we are going to pop the element and we're going to show it. So return s data s top. So with the help of this, we are going to first of all return the element that we are popping, and then we're going to remove this, right? And what happens is that we remove the top and the top also goes down. So we are going one level down. So suppose there is like 3 elements here. So the topmost, so here we can see there are 4 elements. So the topmost element is the third number of element. And if we remove that, we are left with the second element and we can finally go on and call it as our topmost element or the element that is next in line to be removed. So this is basically what happens with s top, and now the new top is the new top. So now let's move on to our last function, which is int peak, and this is again an easy one. And we are going to return the again. Yes. So this is an easy one. We are essentially doing what we have done already and we are returning the top element of this data array. And yep, we are pretty much done. So now let me show you how you can actually implement this int main. And so first we're going to make a new function for the main interval of this, and we're going to write in some stuff like we're going to define a new stack s, and then we're going to initialize this stack s, and then we're going to push some element into this stack. So to this stack we're going to push 10. The data type I have taken for this case here is integer data type, but you can also take some other data type which is totally suited, but you should amend or um, customize your function according to it. And then you can also pop something. So as you can see, the referencing I'm doing here is according to the stack that I'm taking and the stack I've the stack I've assigned in this and defined in this main function. So this is how things work in the console. And here I don't want to give any arguments because I haven't defined anything here in the function itself. So yeah, we are done. And we can also check isEmpty is full through this method. And yeah, thank you so much for watching. Hope you understood stacks and how you can implement them with typedef struct and with ADT. Thank you.